what we wanted to do now is doing some best practices with buildservice, showing how people are working, showing you some examples. I can simply show you existing projects and how they work. Alternatively, we can also package something you want to have packaged, or where you failed, or where you did wonder how to do it best. Does anyone have an issue, a special setup you want to?
I have Debian sources and I want to make RPIs out of them.
Okay. Actually, there's an expert at FOSDEM about that, but it's not me. It's Stefan Kulo, who is not here at the moment. Stefan and Michael Matz wrote a script which converted automatically all Debian sources and created spec files from them. I can show you this.
Yeah, Stefan did a hack project where he tried to import many sources out of a Debian repository and put it in the build service, and basically that ended up in complete flooding of the build service for some days, but most of the stuff finally built and was available for downloading. The question is if the software really worked. We never tested that, of course, because there were thousands of packages.
We tested multiple packages, and the packages which do work nicely and which not wanted are now linked over to another project. So they get really officially released, but upstream is Debian, but built for OpenSUSE afterwards as RPM package.
Okay, this is the login page. We use a Novell account there. That means one has to create an account under novell.com and can use afterwards an account on the build service. This is subject to change. We are currently discussing and probably change to an OpenID account in the future, or make it also possible to use an OpenID account.
Yeah, what to say about that? Okay, that's, the first login always takes a while, but afterwards it's now really fast because we moved the front-end servers. Just the first login which drives one nuts. So the Debian project I wanted to show is there. You can go to the list of all projects. Is your package part of Debian already, or?
No.
Okay. But what we have is the ports project, I believe. So that is indeed a compound. So we have here the auto project, and please excuse that this page takes long to load because it loads 30,000 packages. So it's really a large project, and but the good thing is it does not hazard all the other users anymore, because if something else is to build, then we prefer anything else. Just when the service is boring, then it doesn't build a complete Debian distribution. And in your example, the tools to convert the Debian description to the spec files are part of the tools project. So this is the port Debian-based tools, and here you find the dep to SUSE converter. So you can simply try it. I'm not sure about the current state, but it will become visible at any time in this window. But most of the packages at least compile now automatically without done anything manually. So it's a big progress. Okay. If no one does anyone else have a special thing what he wants to see?
Is there a way of converting SUSE RPM to Debian yet or not? So doing the reverse.
So the reversing is not implemented yet but I mean in the end Debian and RPM works not that different. They have file lists, they have pre and post scripts. Debian has helper tools. So the trick here was that that they use Debian helper tools also on the SUSE system. They fix them and work with them. So when you install this converted RPM, it calls in the end the Debian helper tools and install the system like when you install this Debian one on the recompiled against the SUSE libraries on the SUSE system. So and when it means that we are able to build the majority of the packages, that means all build packages are reused to build the others. So, for instance, a K3B needs the KDLibs from Debian, except they have mapped it to the SUSE ones. But that means at least the installation of all the packages to work also when all others wouldn't be built. So, who of you have seen such the web interface already? Or should I explain something to the project and the web pages? I think I should. If no one else has seen this. So, this is a classic project page. What you see here is, first of all, this is the name of the project. This is more or less a key. It's not really important, but it explains a bit about it. Then we have a list of packages in the middle. These are the source packages which are within the project and maintained. Very important, on the left you see there are two maintainers. So inside of this project only two people can directly change something. One is Richard Günther and one is Stefan Kulo. And they built all these packages multiple times. One for OpenSUSE 10.2, one for OpenSUSE 10.3 and one for OpenSUSE Factory. Factory is our upstream distribution again. So we see here already for 10.2, 5 packages succeeded, nothing failed. In this case, 4 packages for Factory, 4 packages built, 1 failed. Now it would be interesting to find out why it failed. So we can go to the monitor build status, so you can get a fast overview. Yeah, actually for me it's always way faster. Either it's a network here, or I blame the network here. That's not our server. It doesn't behave like that. At least not to me. Yeah, and what you will see here is a matrix in the end with this. Sorry that it takes a. And what, yeah, you can click on the failed packages there, and what you will get is a log file. So you can exactly see what happens wrong. Okay, when it's it's a bit hard to do a workshop if the server is hardly reachable. Yeah. Okay, I try something else instead. So these are the basic projects. That is just a project which has some packages, and these packages get built, and we have some result. The whole thing becomes more interesting when you reuse existing sources. What you can do is look for work in other repositories, but build it in a different way. So one example is the KE backports project. The interesting thing there is that it takes the latest sources we have in our distribution in OpenSUSE Factory of KE applications, but compile it again for older SUSE releases. The advantage of this is that users who have OpenSUSE 10.3 or OpenSUSE 10.2 can install the latest versions on their system. It's compiled against their library, so there are no conflicts, there's no binary conflicts, or if they need to add further libraries and so on, what would be the case if they take the package directly from factory. And for the packager, the great thing is they set it up once. We are creating such a source link. I'll show you soon. And they never ever need to touch it again. The system discovers when, for instance, a new KDE application gets submitted to OpenSUSE Factory, our upstream distribution, and it does automatically rebuild it for all the older distributions thanks to this project setup. So it's a one-time work, never look back again. Of course, it can fail, and you can look inside if you want to make fixes for old distributions as well. Okay, so you see here, it's really a long list of packages that are collected. You see we built for SUSE Enterprise, for OpenSUSE 10.2, 10.3, 10.1, 10.1. Come on. I promise you that it's faster somewhere else. I really promise. Come on. So I click on K3B. This is K3B package, and usually in this package are the sources. Okay. So, here are the files. You can see that these are the sources of the package, and you see there are actually no real files, just a link file. And the link file says takes the sources from the factory project and takes there the K3B. So this file is a static file which needs never to get touched again. The next step is not just to reuse exactly the same sources, but to modify them. I'll show you another example for that. Okay. Jan Blunk is one of our clonal developers, and even though he's one of our kernel developers, not all his wishes succeed and not all his patches he would like to see in our kernel come in. But no problem, he creates his own kernel based on the SUSE kernel. So this is a very similar setup like the KE Checkpoints project. It contains just a source link to the kernel that we have in OpenSUSE Factory. he has a number of packages again inside here, and he builds it also for the Debian people, besides SUSE. But what's become interesting is that besides the link, he has additional files here. These files, okay, it works in this way. It takes first the original sources he specified, namely the kernel sources from the default kernel project, and then it adds these files in addition to them. What you can do, and this file is by the way a diff, so this is a patch. And after these files has been added, the system applies this diff to the directory. When you look into the file, there is a serious conf which comes with the kernel, which specifies which patches gets applied to our kernel. And he modifies this file to get further patches applied. You can do the same with spec files, for instance. So when you want to compile a package in a different way and you want to add some flags in the spec file, you can use such a source link in the same way. So sometimes it's easier just to apply a macro. There's a special link support for in the link file format to add macros, so that you have one spec file and you have some if macro defines and z, for instance debugging or enable experimental stuff, and then you can just specify this macro in this link file. Okay. So this is since this is a notebook I was not prepared to work on, I have to act it now again as a user. The user can go to opensuse.org, software.opensuse.org, and I want to show you the command line client. And the command line client needs to be installed first. So I act as a usual user here. I'm sorry for that. So the software OpenSUSE is our portal where you usually can download our OpenSUSE releases, but also there's also an interface for the additional build service repositories where you can search for all the stuff which is inside. And in addition to that, it features the one-click installation provided by Benjamin. So it's really easy for users to install software meanwhile. You don't need to figure out which repository, add the repository, accept configure the GPG key and all this stuff. It's one click, starts Gast, and you can even select something. So, yes, and I look for OSC. OSC is our command line client for OpenSUSE 10.3. So here we see there's already a version part of OpenSUSE 10.3, but we want to have the latest, newest, greatest. Still the images, yes, it's this link. It's usually a green button, big button on the right side. Okay, I don't wait for that. And this is a YMP file. It gets generated on the fly when the user does click on a file here. So, and this starts a YASM module which tells you what it needs to do. In this case, it needs to add a repository, namely the OpenSUSE tools for OpenSUSE 10.3. And it would install one package, OSC. Advanced, as usual, because any package installation can be evil. What's also possible with this mechanism is when you want to install not only a single package, but you want to define a set of packages for the users. I can show you an example. They have, in the case of DigiCam, it's nice to have DigiCam installed. It's a nice application, but actually, and of course when DigiCam needs a library, this library gets installed also because YAS has a dependency solver. But most likely, in most cases, you don't not only want to have the DigiCam package, but also the DigiCam plugins and the Kitty plugins and all the stuff that really makes DigiCam nice. And in this case, the project has defined a pattern. A pattern is a list of packages in the end. And from these patterns, they are defined once. And the build service uses the patterns and generates for each defined target repository again a YMP file. YMP files are the files which are used for the one-click installation. So again, you maintain one file and you get it generated the proper YMP file for multiple distributions without that you need to log on it. So then, way better for the other installation. Okay, this is the other installation. This tells me there is a new repo, each project has an own GPG key. This is important because per repo there are people who have write access. So if you add one repo and trust them, that does not mean that you need that you trust any other repositories. So because one evil guy is in the build service, not everybody should be able to compromise your system. So therefore you need to accept this GPG key. Good?
I have a question. Which GPG keyring does it modify when you change that?
It's a usual RPM GPG keyring. RPM has a known GPG keyring, and it gets added there as a usual distribution keyring.
Why can't we check the fingerprints?
When?
Where?
The question is what does it help you?
Well, I have to trust the key that is
Right.
the right key. I mean, somebody could sneak in.
Yeah,
wrong.
you can check the key because the key is signed with a global build service key. So you can verify that if it's really signed with that. Apart from that, it's more important that you check, or it would be more important that you check who has access to this project at all, because this is really critical to decide if you trust these people or not. If there's one guy in the project where you say, no, I don't trust him, then you shouldn't install it. And therefore we need a system. This is not really possible at the moment. I mean, you can go manually to the build service, checks there's a list, but it doesn't help you as an end user much. So therefore we desperately need a system where we can guide the users, we can explain how much trustable it is in an abstract way that is understandable. Okay, this software installation was successful. I just started, but for presentation, the patterns case. Just to show the difference. Hello? Oh, I skipped it. So the DNS resolution has taken 5 seconds. Okay. I skipped it. So, and if you check I open a new console. So OSC is our command line console. I just want to show you when I run OSC the first time, for instance, to check out my home project. This is what you get by default when you create a new account. It asks me my account name and my password. It stores it on the hard disk like SVN or CVS is doing as well. I mean, there are some complaints that we do store the password, but you don't want to type it again and on every action you do with OSC. It would hurt too much, I think. And it's the same procedure as SVN or CVS. It's working. So, of course, OSC is also using the network. It's as fast as the web interface at the moment. Okay, but now you see it's the output already is similar to what you see with SVN. You see the base for added new file and downloads my project. I think I aborted after the first package. That is not nice, but and this became significantly faster last week actually because we improved our server infrastructure. So usually it would be done already.
Please stop downloading.
Yeah. It's hard to get a working network on a fair as suddenly thousands of people appear. So, I'm here, this is an Excel package. What I can do here is looking at the results. This is similar to what we have on the monitor page. You have not seen yet because it's loading most likely. Oh, what happened? We have a monitor page meanwhile. Okay. Okay, so in this case, it's a perfect package. Everything is built. Just and then, for demonstration, I add some bugs. So this is the build requires line. The build requires line is the list of packages which are needed at building time. So this is important because for each package build, we set up a complete new system. This is really required to guarantee that the build is reproducible, and also because theoretically any package could harm the system already. So if there was once a package installed which harms the system, you suddenly have a different system and you wonder why suddenly your package build does not work anymore. So it wouldn't be reproducible. And of course, because multiple people from multiple projects building on the same build hosts, we need to reset up it because we do not want that person A from project A is doing something which has an effect on project B. So, there's a default set of packages which gets installed. It's an absolute minimal system. Anything else needs to be specified. You see, there's by default not even a compiler installed, so we need to specify it. The devil packages needs to be specified and so on. The good thing is that, again, the dependencies folder works here. So when you want to compile a KDE application, it's enough to add KDE libs devil because all necessary dependencies for that are required by KDE libs devil. So it's really easy in that regard. When I add something here what does not exist, so this is my change. You see it works as this SVN or not. Okay, don't wait for now. I check in. So it uploads now the spec file because it's the only spec file, only file I have modified. How much time do we have? Sorry for that. Okay, I try to Okay, what you would see is that it would try to start a new build, but then suddenly discover that it actually can't, because does not exist, surprisingly. So we have the expulsion error, we call it here. What we can do is, for instance, does not exist might be just the name of a package which does actually exist, but under a different name, because some distribution has a different name for another one. Usually we map these automatically, but it might be caused that I have another package inside of my own project which causes this. What I can do now is I added the project config of my own project. Or better, I show you an existing one of OpenUser 10.2, for instance. So the project config is a config for a project which defines basic setups. This is a really long project configuration. The base distribution needs to have a project configuration which defines the basic setup. And usually, in standard cases, you don't need to touch it. But you can. You have every option that you can modify your project config and just set up your own system as well as it's done in the base system. Or you can override the base system things. I do not want to go into detail, but the first line defines that the result will be RPM MB, that are Jung metadata, repo data, be an output, and YMP files. We could, of course, also add other types here, like the former SUSE formats, and we get the SUSE metadata. You can get define the Debian metadata if you want. This is a really long setup for the initial build system, and especially for old distributions or foreign distributions which are not built in the build service, there are bug fixes inside, because packages, our old OpenSUSE distributions were quite broken actually, but also foreign distributions are broken to some degree because packages do not require something what they could do, but they don't work. All this kind of stuff can be fixed in this configuration. We can also ignore dependencies because it would lead to cycles, for instance, or it would just slow down the build, but it's actually not necessary. So we can override RPM dependencies here. And this is the interesting part. These are substitutes. So these are definitions of packages which does exist in this project with a different name. So what you read here is libOpenSSL Devil does exist here in OpenSSL Devil. So when there's a build requires libOpenSSL Devil, it will get changed in the beginning of the start of the build to OpenSSL Devil. The nice thing about this is you have one spec file to maintain, but you get source RPMs for 10.3, 10.2, and so on, and these contain the modifications for the target distribution. That means the source RPMs are buildable for your users again. You get automatically get a fixed spec files inside of them.
Quick question.
Yeah.
Can you use this to map package names to different distributions, like so that because like right now, for instance, I have
Exactly. That's what we're
do
doing.
the if defs or the ifs inside of this. So you know, I want to say that
Yeah.
this is package X, but on Fedora it's this, and
And
this.
this is exactly what we are doing. When you want to see this, what we are doing, you can go to the Fedora distribution, looking at this.
Okay, so it's done on the metadata for the project.
Exactly.
So does this apply to my pack? Can I edit these at my package level, or is this at the distribution level?
You can apply this to your project, but actually this you don't need anymore, because when you build against this project, you get them for free. You can add it, when we have lacking something here, or you want to test something, you can add it in your project and report back, then you should add this.
Okay.
And then everybody gets this change.
Right.
So what you see also is also little at Fedora, for instance.
Fantastic.
So it's, all this work is taken away from you.
Ah, it's awesome.
Question.
Yep.
Is this specified in terms of the usernames or also in terms of all the other distributions names?
This is a case-by-case decision. We need to avoid cycles. So we cannot, we need to be careful that we not map it vice versa.
Right.
The long goal should be that we define standards in the long run. For instance, the JPackage people agreed to define Java Devil, and Java Devil should be mapped to a correct thing that you get all needed Java packages, independent if it's GCJ, IST, Sun Java, whatever. So, but it's a case-by-case decision.
Is this documented on the OpenSUSE wiki yet, this particular feature?
Which one? This is the project config. This is documented, yes. But I would recommend to look at the existing configs. You don't know what are really real-life examples. And yeah, what I can do, just to show it, is with the -A I can edit my own. So when I do it in my home project, I suppose it's empty. Maybe not. It's empty. And I can add or replace any rule which exists. So if I want to substitute, so, okay, does not exist, and I leave this, I add nothing behind, it means it does remove it. That means I have a typo. Substitute, I'm too stupid. Substitute. What? Okay. So, what is
Zweite T eigentlich.
sorry. Shoot. So. What? Substitute. What? S-U-B-S?
Ja.
But that was no. Usually I don't need this. Right. This is ignore. Okay. Our base system expert. Okay, I can also ignore him. Why should I? I'm too stupid. Okay, what I can. I'm too stupid obviously, and in this case I don't understand it. What I do now is I add a -H to get the server answer. So he explained, hopefully does not exist. He does hopefully explain to me
Is that your actual name?
What?
You have a lowercase u for your project.
No, I'm just. But when I'm too stupid. Yeah, right. Yes. I do it wrong regularly. Ignore. Okay. Does not exist. This is really, we need to report this better. There's a bug report open for that.
Yeah.
Okay, now it works. Okay. And you see, it does build again, even though I have a spec file submitted which is broken. Of course, usually I should not add such stupid things. Okay, anything else you want to discuss? Otherwise, I will be there tomorrow the whole day on the booth and we can